Alright, my name is Bryce Butler, and this is my video for networking for games. So the gamertag that's going to be used for this computer is going to be Yoshi, and let me sign in. This is the main menu that I have for my version of OmegaRace. All it has is the controls and press A to create or press B to join lobby. So I'm gonna create a lobby. So while the host is waiting for another player to join, there will be a yellow text in the upper left hand corner saying waiting for player to connect, and above the first player lives is the name of the host, which is Yoshi, since I created the lobby. On my other computer, I'm gonna join, and there it is. So once both players join, then the match actually starts. As you can see, just like with the host, the second player's gamertag appears over their lives. I'm going to move around, and I can fire, things collide, and I can also set a bomb. On the other side, I can spin around, fire missiles, things collide, set a bomb. So I'm just gonna fly around for a bit and kind of shoot things, but while I'm doing that, I'm gonna talk about what I did for the data-driven aspect of the game. So I had several different packet types or data packets, I guess. I had four packet types. The first one is a ship data, and the ship data only contains an integer and a player ID. So the integer is actually a flags integer. I have an enum ship flags, which is each enum is a single bit in a 32-bit number. And so I have like a flag for rotation, or for player plus forward, or fire, or bomb. And so once I interpret the data later on in my input queue, I basically test that integer against various flags to determine what to do. It was just my way of dealing with it, I guess. The second packet that I have is a game object creation packet, and so this will tell. So this is only sent from the server, and once the server and the client both receive it, they create a game object, and so the packet has the game object ID that the new game object is going to have, as well as the player ID of who owns it and what type of game object it is. Is it a player 1 missile, player 2 missile, or a bomb, or whatever. And then I have collision packet, which just takes two game object IDs and the point of collision. And then I have a physics packet, which is a list. So I have a physics list packet, which contains a list of physics data packets, which is just the position, rotation, and velocity of a game object with its ID. So those are the packets that I had. Then I had a header packet, which is actually what is sent and serialized in the input and output queue. The header contains the type. The type is a enum queue header type that tells you what type of data packet it is. Is it a ship data, game object creation data, collision data, or physics data? And this, and then it also has the actual data as an object, and it also has a delegate process function. So then when the output queue is called, process output, it'll basically call the header packet's delegate function. So that will process each packet as it needs to be. And this was my way of getting around a giant switch statement, which I find are ugly. And so the output queue also has an add packet function. It actually has many of these, and each function is specific for the data type. So I have an add ship data function, and that will take in a ship data parameter, and then that add function will create a header and actually enqueue that in the output queue. Then so for the PA7 aspect, the process function that the delegate's process function will actually convert the data into a packet writer and then send that data over the network. And then the input queue works very similar to the output queue. It has add functions that create a queue header, and these queue headers will have a delegate that will tell them what their process function is. And then once they get to their process function, they actually deal with the actual using the data in the packet to make something happen in the game. So that's where like the ship data will be processed as, oh, the turn left flag was set, so therefore rotate the ship left or counterclockwise. So the match just ended, and I was returned to the main menu. On my other computer, I'm going to create a lobby, and then on this computer, I will join that lobby. And so for the player that joins, it's thrown right in. So you can start. So for this computer, it's the green ship now. Things still collide, and I can still fire missiles and bombs. So yeah. So then so the output queue pushes or writes the packet writer and then sends the data out. How I have the packet reader working is the packet reader starts creating a queue header, so it gets the queue type or the queue data type, so is it ship data or collision data or whatever, and sets the other parameters in queue header. And then I have a dictionary that takes in a queue type enum and outputs a delegate, and so this delegate actually is and this delegate takes in the packet reader, and that packet reader then creates each data and then adds it to the input queue. It calls the input queue's add function. So I have three or four different delegates floating around, so I could avoid switch statements and if statements. And since enums are essentially ints, the dictionary lookup isn't super intensive. So that is the ships moving along with the data driven, and let me finish this match so I can go back to the main lobby. So everything I just talked about will be explained in my checklist if you want to read through it more, or you're more than welcome to go through my code and look at how everything works. I will also have a link in the description to my other video that is just a recording on my phone of both computers side by side and me moving on one computer and it showing up on the other. So again, that will be in the description below. And thank you for watching. I tried to make it short.